Intercepts, horizontal, and vertical lines. First thing we're going to do is find intercepts. We can find intercepts and we can use these to graph, especially when the equation is in standard form, ax plus by is equal to c. Again, standard form is when x and y are on the same side. To find an x-intercept, this is going to be the point where the graph crosses the x-axis. Let y equal 0 and solve for x. So let's take a second and look at a grid. And just think logically that any point on the x-axis is going to be a number and then 0. So for example, that point I just put right here would be over 2 up 0. So to find any point on the x-axis, you let y equal 0. So an x-intercept will be a number and then 0. The y-intercept, a point where the graph crosses the y-axis. Let x equal 0 and solve for y. Again, if you're thinking logically, any point on the y-axis has an x value of 0. You go over 0 and then up or down a value. So if you forget, where do I substitute in 0 for x or y? Just draw yourself a picture and think, all right, anything on the x-axis has a y value of 0. Anything on the y-axis has an x value of 0. Identify the x-intercepts and the y-intercept on the graph. I will tell you x and y-intercepts need to be written as ordered pairs. So first, let's find the x-intercept. Notice that this grid is counting by a halves. So the point right here is at 5. So that is at 5, 0. The y-intercept is going to be here, and that's going to be 0, 2. My next example, what is the x-intercept? What is the y-intercept? Well, in this case, it is actually crossing at the origin. So the x and the y-intercept are 0, 0, and it crosses at the origin. So in the last lesson, we graphed lines using a table. And now we're going to use another method called intercepts to graph. Find any intercepts and graph. Example 1, 5x minus 3y is equal to 15. So the table is already set up, so we're going to plug in 0 for y. And I call this the cover-up game, because really what we're doing is we're going to cover up the y value, because when we plug in 0 for it, this term right here is going to be 0. So I just kind of cover it up, or I erase it. So then I just have 5x is equal to 15. So 5x equals 15, divide both sides by 5. X is equal to 3. So that gives me the ordered pair 3, 0. Next, I'm going to plug in 0 for x. So that's going to be 5 times 0 minus 3y equals 15. Again, this is 0. So I have negative 3y is equal to 15. Divide both sides by negative 3. Y is equal to negative 5. So the y-intercept is at 0, negative 5, and then connect the dots. Example 2, 2x plus 3y is equal to 6. Plug in 0 for y. That gives you 2x equals 6. Divide both sides by 2. X is equal to 3. Plot the ordered pair 3, 0. plug in 0 for x. So that would just be 3y is equal to 6. Divide both sides by 3. Y is equal to 2. The y-intercept is at 0, 2. Connect the dots. And what you might notice is that I didn't draw a very good line right there. What you might notice in the two equations is that the coefficients of x and y are factors of c. So what I just said was for number 1, 5 and 3 are factors of 15. In other words, the coefficients of x and y divide evenly into the constant. Same with example 2. 2 and 3 are factors of 6. So when the coefficients are factors of the constant, then using intercepts is a very good way to graph. All right, example 3. Fractions don't scare us. We're going to plug in 0 for y, which gives us 1/2 x is equal to 2. Multiply both sides by 2 over 1. We get x is equal to 4. So the x-intercept is at 4, 0. And then plug in 0 for x, so that would give me negative y is equal to 2. Divide both sides by negative 1. Y is equal to negative 2. 0, negative 2. Connect the dots. All right, here's some steps. To find any intercepts for a graph of ax plus by is equal to c. To find the x-intercept, set y equal to 0 and solve for x. The x-intercept would be c over a, 0. Let me show you how I get this. So I have ax plus b times 0 equals c. So if I solve for x, ax equals c, and divide both sides by a, x is equal to c over a. I wouldn't memorize that. I would just know that to find an x-intercept, you plug 0 in for y. Number 4, to find the y-intercept, you're going to set x equal to 0. We're going to solve for y. So our y-intercept will always be 0, c over b. You're like, oh, what is she doing? Well, I'll show you. If you substitute 0 in for x, you have by is equal to c. Solve for y, divide both sides by b, and y is equal to c over b. All right, let's talk about horizontal and vertical lines. A horizontal line is y equals any number. So my red line right here goes through the y-intercept of 3. It is a horizontal line, and a horizontal line is in the form of y equals the y-intercept. So this would be y equals 3. And in the box, a horizontal line with a y-intercept of 0b has an equation of y equals b. So I could have written the y-intercept as 0, 3. A vertical line is x equals any number. So this line goes through 3. It's the ordered pair 3, 0. It's a vertical line. So the equation of this line is x is equal to the x-intercept, which is 3. So now we'll practice graphing. Example 1, graph x is equal to 5. X equals is a vertical line. So go to the 5, put a 5 on x, which is here, and then draw a vertical line. Example 2, y equals -3. So go to -3 on the y-axis and draw a horizontal line. Example 3, x equals -2. Go to -2 on the x-axis. Draw a vertical line. Example 4, y equals 6. Go to 6 on the y-axis and draw a horizontal line. If a line has no y-intercept, then the line is vertical. And this is provided that it's not x equals 0. If a line has no x-intercept, then the line is horizontal. Let's look at some more horizontal and vertical lines. Number 1, find the equation of the line using the given information. Number 1, this is a vertical line going through x equals -2. So the equation of this line is x equals -2. Number 2, this is a horizontal line going through -1. So this is y equals -1. We can also get equations of lines from a table. Well, if you notice this table, all the y values are the same. So the equation of this line would be y equals 5. And you don't have to take my word for it. You can make yourself a grid. And if you go to -2, 5, -1, 5, 0, 5, 1, 5, 2, 5, if you plot those points, you are going to see that this is a horizontal line going through 5. Number 4, all your x values are the same. The equation of this line is x equals -8. It is a vertical line. Number 5, we want to graph a vertical line, or we want to write the equation of a vertical line passing through the point 2, -4. But I'm a picture person, so I want to see what this looks like on a graph. So if I go to 2, -4 and plot the point, and I want a vertical line, well, that would be what I just drew. And that vertical line would be x equals 2. For number 6, I want a horizontal line passing through the point 3, 5. If I go over 3 and up 5 and I plot the point, and I want a horizontal line through that point, that's going to be the orange line I just drew. And that is a horizontal line, y equals the y value. So that's y equals 5. Number 7. We want to find the equation of the line that is perpendicular to x equals 4 and passes through the point -4, 0. We want a perpendicular to x equals 4. So I'm going to graph x equals 4. And this line needs to pass through the point -4, 0. So if we want a line going through the blue point that is perpendicular to x equals 4, perpendicular lines form right angles. A vertical line is perpendicular to a horizontal line. So what I just drew in blue would be the line. Well, what is the equation of that line? That's a horizontal line, which is y equals, and y is equal to the y value of the point. So again, perpendicular are going to form right angles. So vertical and horizontal lines are perpendicular. Number 8, parallel to y equals -4. So here's y equals -4. And passing through the point -2, 8. Well, parallel lines are like railroad tracks. So if you have a horizontal line, the parallel line will be horizontal. If you have a vertical line, then another vertical line will be parallel to it. So I want the horizontal line that goes to the point -2, 8. So this is going to be y equals, again, the y value, which is 8. So I put stars by these. These might take a little extra work, but just know perpendicular lines, one's going to be an x equals, one's going to be a y equals. If you have a parallel lines, then they're both going to be either x equals or y equals for their equations. All right. And my last example, let's interpret some results here. The distance a driver from home is illustrated in the graph. So our x-axis is time in hours, our y-axis is distance in miles. So at time 0, the driver is 200 miles from home. So when the driver starts, the y-intercept is at 0, 200. Question number 1, what is the x-intercept? Okay, well, the x-intercept is right here. So that is 4, 0. Interpret what it means in the context of this graph. Well, we just got to use our labels. In 4 hours, the driver is 0 miles from home. So another way to say that, in 4 hours, the driver is home. Well, what is the y-intercept? Well, that one's up here. The y-intercept is go over 0 and up 200. Well, what does that mean? Well, that's what's happening at time 0. That's what's happening at the start. So I would write the driver starts 200 miles from home. And there you have it. Have fun working on math.